Right, good morning, grade 9s. I'm sorry I can't be there this morning, but I'm going to ask your teacher just to pause and play the homework part so you guys can copy down everything and mark your work. And then if there's any questions, when I see you guys again, we can then answer those. Or if you like, you can text me personally as well. I will be coming back to school later today. So if there was a major problem, you can quickly pop in, let's say, during break. Okay. All right. So let me just move that one. Okay. There is A, C, and E. E's number 5 is on the next page. So maybe your teacher can just pause now and give you some time to write these down. Okay, there's number 5. Because we have done a similar exercise in the previous period, I am not going to go through all the homework again, just to limit the time for this video as well. Okay, so remember, any questions, come ask me later today or just send me a text. Right, so today we've got to do geometric patterns. Okay, now we've finished with numeric. We now have to do, we said at numeric we have got constant difference. Okay, but now we are going to have a constant ratio. Now, what does the constant ratio mean? It means that, remember when we had constant difference, we were adding or subtracting the same number throughout. But now it means that we are multiplying, so I forgot about that, oopsie, multiplying or dividing with the same number. So just to show you what I mean, I wrote down a number pattern below, 2, 6, 18, and 54. You would see that, what did I have to do with 2 to get to 6? Yes, okay, I could have added 4, but then if you got to the next one, you'd see that it's not plus 4 again. So that's how I knew that this would not be a numeric pattern, okay, because it didn't have a constant difference. So, but what you could have done is 2 times 3 gives me 6, and 6 times 3 gives me 18, and 18 times 3 gives me 54, meaning this times 3, the constant number that I am multiplying with in this case. Remember, it could be multiplication or division. Okay, this example is just multiplication. So because I'm multiplying with the same number throughout, constantly doing the same thing, that means that the times 3 is my ratio. Now, I am not going to say times 3. We're just going to say that the ratio is 3. Okay. I'll show you when it gets to division just now. Okay, so basically ratio is 3. Let me just quickly show you if it was the other way around. I'm going to do it on that side. If my number line, I'm going to use that same one, I'm just going to switch it around. It was 54, and then 18, and then 6, and then 2. Okay, now you would see that instead of multiplying with 3, I would have been dividing by 3. No, but right over here you saw that I said R, which is for ratio. Ratio is 3. Now, I can't say again, ratio is 3. So when it is division, it would be a fraction. So it would be 1 over 3. So what's actually happening here, instead of divided by 3, I can also say times a third. Because 54 times a third is going to give me 18. So multiply with a third and dividing by 3 is actually the same thing. No. So just be wary of that. Okay, now you will see that the explaining in the textbook is so long and very very complicated. So I'm going to break it down and give you the formula that you're in any case going to use from grade 10 onwards. So when we work with geometric patterns, we will have term n is equal to a, and remember that little dot means times, r to the power of n minus 1. Now, previously you guys were taught about the nth term. That's our general rule, right? Now, this is where we would start with when we work with geometric patterns. Okay, so that formula will never change. The only thing that is going to change is you're actually going to substitute a number in where we've got A and a number where we've got R. So what do those two stand for? The A, why is it not, sorry. Sorry. Oh, come on, why is it doing that? A, there we go. A is actually your first term, okay? And then obviously R will be your ratio. Okay, so I'm going to rewrite what we had just now. We had 2, 6, 18, and 54. You don't have to rewrite it again. I'm just writing it here because you've got it already. I just want you to see it on the slide. So we said because it was times 3 times 3 times 3, we knew times 3 times 3 times 3, we knew that the ratio R would be 3. Okay, so if we would have to use this, term n is equal to, A is the first term. And what is our first term? 2. So instead of A, I'm going to say 2. And then there was a little dot, which means times. I'm going to show you just now, you can, instead of the dot, use brackets as well. But I'll show you the dot one first. Okay, so A times. And then R, we just worked out that R would be 3. And then n minus 1. So that is then my nth term, or my general term. Okay, general rule for that sequence. Okay. What you could also have done is, I'm just scared that you guys might not see that little dot, and then when you put it into your calculator, you also say 2.3, and then it's going to be totally wrong. So what you can do is just put brackets around. So 2, and then brackets around the 3. Now it still says 2 times 3 to the power of n minus 1. So that, I think, would be the best option for you guys to write. Okay, so let's just work through a few examples. Remember, if you guys are still copying, the teacher can just pause and you can finish copying. Right, so the sequence. Let's first find out, is it numeric or geometric? Okay, what would I have done to get from 3 to 6? I am going to multiply with 2. And to get from 6 to 12, times 2. And 12 times 2 is going to give me 24. So obviously, this is a geometric pattern, which means that my ratio R will be 2. Okay, now if I asked you to get the nth term, the general rule, you're going to say term n is equal to A times R to the power of n minus 1. Okay, which means that A is term 1, and our term 1 was 3. So 3. R is my ratio, and over here we said ratio is 2, and then to the power of n minus 1. Please, people, do not go and multiply the 3 and the 2 with each other. Why could we not multiply them? Because of that exponent. Because that exponent only applies to the 2. It's got nothing to do with the 3. So it would not be mathematically correct if you were to multiply these two with each other. Okay, so please do not do that. This is where we stop. Okay, good. Let's look at another example. I've got 2, 8, and 32. Okay, so what did I have to do to get to 8? I multiplied with 4. And then 8 times what gives me 32? Also times 4. So ratio would be 4. So let me get our general rule, or the nth term. It would be a times r to the power of n minus 1. Okay, so a term 1 is 2. So I'm going to say 2. And then r, my ratio, is 4. And then to the power of n minus 1. Good. 2 more examples. I'm going to do it a little bit more like your homework is going to be. I'm giving you the following number sequence: 1, 3, 9, and 27. Okay, I'm telling you that it is a geometric pattern. So let's get the ratio first. I had to multiply with 3 to get from 1 to 3. And then 3 times 3 is going to give me 9. And 9 times 3 is going to give me 27. So the ratio of all r would be 3. Okay, so let's determine the nth rule. At number 1, determine the nth rule. So term n is equal to a times r to the power of n minus 1. So let's go substitute n. A is term 1, which is 1. And then r was 3. So 3 to the power of n minus 1. Alright, so now that we've practiced how to get the nth term, we must now determine term 10. Now the same as what we did with numeric patterns. We know that our general rule, or the nth term, was 1 and then 3 to the power of n minus 1. But what we're going to do now is we're going to work out term 10. Okay, so can you see that instead of an n, I am using 10, which means that over here, where I also had an n, I must now substitute in 10. Okay, so let's do that. So you would have the 1 stays and the 3 stays. And then I've got 10 minus 1. So basically that is 3 to the power of 9. But you put in that whole thing into your calculator just like it is. So that's going to give you or at least 19,683. Okay, please remember to put in your brackets as well. All right, last example, number 4. Number 1 says, write down the next 3 terms. Okay, so let's first figure out what would my ratio be. So 8 times what is going to give me 16? That would be times 2. Okay, so 16 times 2 is going to give me 32. Now, for the next 3 terms, I've got to take 32 and multiply it with 2, so you're going to have 64. That I also have to multiply with 2, so it's going to give me 128. And then again, times 2 is going to give me 256. Okay, so that would be my next 3 terms. Now at number 2, they're asking me to determine the nth term. So term n, we said a times r to the power of n minus 1. So let's go substitute n. A is term 1, which is 8. So I'm going to have 8. Remember your brackets. The ratio, we saw it would be times 2 throughout. So my ratio, or r, would then be 2. And then to the power of n minus 1. Okay. let's go determine the 10th term. So then term 10, remember, what we're going to do now is where we had an n, we now put 10. So over here where we had n, I'm now also going to put 10. So I'm going to have 8 times 2 to the power of 10 minus 1. Okay, so if you put that into your calculator, you would get 4,096. Okay, I hope that you guys understand. Your homework is going to be exercise 3, that's on page 74, and you're going to do A, D, G, J, and M. Just please read carefully. It says, for each of the following number patterns, you've got to do 4 things for each one of them. Number 1, write down the constant ratio. So basically, like we did over here, write down the ratio first. So R is equal to what? Then number 2, write down the next 3 terms. Okay, like we did over here. All right. So write down the next 3 terms. Number 3, determine the nth term. That is what we did here at number 2, determine the nth term. And then number 4, determine the 10th term, exactly, like we did over here. Okay, so you've got to do 1, 2, 3, and 4 for each one of them, A, D, G, J, and M. All right, have a nice day, you guys. Bye-bye.